Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to start solving questions on Biostatistics 1 and then Statistical Method 2. So in our previous video on the list on Statistical Method 2, we have done quite a lot on random variables, discrete probability distributions, continuous probability distributions, confidence intervals, and hypothesis testing. So please, if you haven't watched the videos on that, it will be of your own benefit to take your time and go through the videos one by one in order to equip you in learning how to solve questions on random variables. So here, today we are starting with random variables. In our subsequent videos that we are going to make, we are going to tackle discrete random variables, continuous random variables, confidence intervals, and hypothesis testing, solving questions on these topics in order to enlighten yourself when you get yourself in touch with random variables questions in your examination. In fact, random variables questions are very simple. Kindly follow this channel and you are going to be blessed. Amen. So let's continue. So question 1, we are having expectation of x and y is equal to expectation of x times expectation of y if x and y are independent. True or false? So when x and y are independent, we are just saying that, for instance, please, I'm coming. If we have expectation of x times expectation of y, is going to be expectation of x times expectation of y, of which this can be written as, so you see that this is inside this one, so it's just multiplying. So what you are going to do, you are just going to separate them, right? So here the expectation of x will stand on itself, expectation of y will stand on. Since they are independent, we are going to have expectation of x times expectation of y, of which is equal to this one, and the answer is going to be true. It said x is a variant between 0 and 3. The value of x squared is given us, right? So it's just lying between 0 and 3, and of which if you put s to be 0, you are going to get 0. But when you put s to be 3, you are going to get 3 squared, which will give us 9. So our answer here is 9. Or we can just assume that our f of x is equal to 1. And if you want to find, this is a continuous random variable. If you want to find expectation of x, here we are going to get expectation of x squared is equal to integral from a to b s squared times f of x. So this is what you are going to have. And then you see that expectation of x is assumed to be 1, right? So here we are going to integrate from 0 to 3 s squared times 1 dx. So here we are going to get s raised to the power, once you are integrating, we are going to get s raised to the power 2 plus 1 divided by 2 plus 1, moving from 0 to 3. Then once you substitute in this one, we are going to get 3 raised to the power 3 divided by 3 minus 0 raised to the power 3 divided by 3, of which you are going to get 27 divided by 3, and the answer is 9. I think the first method is very simple than this one, integrating this one. So I will entreat you to use the first method, right? So the question 2, the answer is D. We are having answer D. He said, how many types of random variables are there? Right? We are having 3 types of random variable. Basically what we learned in our slides is discrete random variable and continuous random variable. We have another random variable, so please kindly check that one and share it at the comment section below, right? Yes. And the question 4 is saying that a random variable does not always require being measurable. Yes, a random variable does not always require being measurable, because you have 2 types of random variables. We have discrete random variables and continuous random variables. Discrete random variables are countable, whereas continuous random variables are measurable. So here it does not require being measurable. Always a random variable doesn't require that. So the answer is true. He said question 5, a coin toss is an example of dash random variable. If you are tossing a coin, you are going to get a head and a tail. So this is it a continuous random variable or a discrete random variable? When you are tossing a coin, it's an example of a discrete random variable. Question 6 said expected value of a discrete random variable x is given by, you are having expectation of a discrete random variable x is given by. So you see, this is a discrete cases, right? So when it is a discrete case, it's just summation of what the random variable s times the probability, right, of that random variable, of which that answer is what? C. Answer C. So you are just going to take the summation of x times the probability, right? And then for the continuous random variable, we said if x is a continuous random variable, then the expected value is given by, you see, this is a discrete random variable. That's the reason why we sum. But for continuous random variables, we integrate them, right? So if you want to find the expectation, that's the mean. That one too is also integral of our random variable times our function f of s dx, right? So this is how we are going to find our mean of x. So what about if you are asked to find expectation of x squared? So that one to be integral of s squared times f of x dx, right? Since here is square, this part too will also be what? Square. So here our answer will be what? Answer C. Answer C. Question 8. Question 8 is saying that if our expectation of x is 2 and expectation of z is 4, then expectation of z minus x is given us. So you see that expectation of z minus x is given as expectation of z minus expectation of x. So expectation of z minus, and then we have expectation of z to be 4, expectation of x to be 2. Here we are going to get what? 2 as our answer. So here the answer is what? A. Answer A. And then question 9. So for question 9, we are having summation. He said if summation of p of x is equal to k squared minus a, then the value of k is, so if you have summation of probability of x is equal to what? 1. When we sum all the probabilities, you have to get 1. And here we are just saying that this summation is equal to k squared minus 8. So it means that I'm going to find the value for k. And then you see that this is equation 1. Please give me some small time. Equation 1 is saying that summation of p of x is equal to k squared minus 8. And summation of p of x is equal to 1. So here is equation 1. And here is equation 2. Right? So we want to equate equation 1 to equation 2. Right? So here I'm going to get k squared is equal to, k squared minus 8 is equal to 1. So k squared is equal to 1 plus 8. We want to group like terms. We are going to get k squared is equal to 9. Square root of k, we are going to get k is equal to plus or minus 3. Here our k can be equal to 3 or negative 3, of which we have 3 here. So that will be what? Our answer for that. And then we are saying that what is the value, what is the mean and variance for for standard normal distribution? We know that our PDF for normal distribution 1 over square root of 2 pi r square, square root of 2 pi sigma square times e raised to the power negative half x minus mu divided by sigma all squared. So this is our PDF, right? But in order for us to calculate for the probabilities, we cannot integrate this whole function. So what you do is that we use the standard normal distribution to find the probabilities of what? This normal distribution. And in order for us to use the standard normal distribution, we just assume that our mean is equal to 0 and our variance is equal to 1. So for the mean and variance for standard normal distribution, we are having a mean of what? 0 and a variance of what? 1. Yes. So that is what we are having. We are at question 11, and then we have been asked to find the value of m. And then you see, this is the table. We said use the above table to solve the questions above, right? And you see that here is our x and here is our f. So the f here is just the probabilities of the above random variables. And then we know that we have been asked to calculate for the m, right? And then you could see clearly here that these are probabilities, and we learned that summation of what the probabilities is equal to 1. So when we sum everything and equate it to 1, we're going to get our m, right? So here having 0.3 plus 0.2 plus 0.1 plus m plus 0.2 plus 0.1 is equal to 1. So here we are going to have when we add everything here, we are going to get 0. So here will be 0.3 plus 0.2 will be 0.5 plus 0.1 will be 0.0 plus 0.2 will be 0.8 plus 0.1 will be 0.9. So we are going to have 0.9 plus m is equal to 1. We are going to have m is equal to 1 minus 0.9, and then our m will be giving us 0.1. So this will be our m. So here our m will be equal to 0.1. So this is how we can calculate for This is how we can calculate for our missing value from a discrete cases, right? So this is how we are going to calculate for that one. And then we are to find the expectation of what? X of that. We know that expectation of X for a discrete cases, will be giving us summation of what? Our X times the probabilities of that random variables. So here we are just going to multiply this one by that and then just add it. So I'm going to leave this one to you as an assignment. So please kindly make sure you do it and share it at the comment section below, so that when you are right, I'll reply you that you are right. So kindly solve it and then share it at the comment section. Thank you. This is Statistics and Mathematics YouTube channel. Kindly subscribe, like and share so that this video will get viral to your friends. And then in our next video, I'm going to tackle questions on discrete probability distribution. So please, if you haven't subscribed, kindly subscribe and stay tuned on this channel to solve more questions on statistical method. Thank you. Bye. Have a blissful day.